Okay, so given a function on a graph, we want to find the inverse of the function. So in order to do that, we first need to identify 2 points that are very clear. And for me, I realize that that's easiest with the x-intercept and y-intercept when it's very distinctive. Otherwise, find 2 points where you can easily find your rise over run. So if we start at negative 10 to 0, it runs 10 and then it rises 5. So our rise would be 5 and our run would be 10, which means my slope is 1/2, right? And my y-intercept is 5. Once we got that, we can now write it in function notation. F of x is equal to 1/2 x plus 5. In order to find the inverse, we're going to change the function to an equation, substituting y for f of x and leaving the x where it is. So changing the equation, it becomes y equals 1/2 x plus 5. Remember, you guys can pause whenever you need to. Now we circle the x and y to remind ourselves what we need to switch. And when we do that, we get by switching the x and y, we get a new equation of x equals 1/2 y plus 5. After we do that, we now solve for y. And you do that by doing PEMDAS backwards, or the order of operations starting from adding and subtraction to working the other direction. So we would then subtract 5 from both sides, which would definitely give us x minus 5 equals 1/2 y, right? Now we multiply both sides by 2, so that'll simplify to 1, which would give us 2x minus 10 equals y. So all we need to do now is write that in inverse notation. So that would be the inverse of x So again, that would be the inverse of x, which is f raised to the negative 1 power of x. We say that inverse of x is equal to 2 minus 10. Now, you can graph both of these, open up a table on Desmos, and your domain and your range should switch if this is the inverse. So whatever your domain is for your function, that should become your range for your inverse function, and vice versa. Good luck, rewatch, pause, do whatever you need.